Oh, I pressed the wrong button again.
Oh, it never fails. Never fails.
Oh, it's different setup. It's new. It's all fangled.
You know, you'd think eventually we would get this all sort of just automatic and down pat.
Make life too boring now, words.
I know.
Make everything, life would be boring.
Well, hello, Simon. Good to see you again, even on a weekend. It's like it's not just
on a New Year's Eve, no less, as well.
The very last weekend for us still.
And then we'll be able to tell everyone at the end of the show, we'll see you next year. And it will.
That's right. We can tell everybody we'll see them next year, even though it's only going to be a few days from now. Yep. I'm still sending out all the announcements. So if I look distracted, I'm like trying to figure out all the places I normally send this stuff out to and posting the right stuff. It's coming out.
Sorry, everyone. This is just trying something different here. Hopefully, people are tuning in as we speak. So we're going to continue where we left off before. I don't know if anyone joined us for Wednesdays. I think it was Wednesday. So much has happened over the last few days. For Wednesday's live Hump Day Q&A that we did on YouTube. But we're streaming out to Twitch and we're streaming out to my ex Twitter account. So let's see if this makes any difference.
Your current Twitter account.
I know we get comments. I don't know if they're just from YouTube or if they're from everywhere. So we'll see. That's how we're going to do this. Okay, and Happy New Year to everyone, first of all. We're going to continue where we left off before, and I'm going to walk you through what I kind of fixed the bug that we were having before, so I want to walk you through what the problem was, and then how we went to fixing it, and then we'll jump into some live coding, and maybe we'll try and sort of, I was thinking about doing maybe like a fireworks simulation. And that can be at the very end of the game. So we're trying to. So for those that don't know, there was a game called Rainbow Islands. Rainbow Islands. I remember playing this when I was a kid, and I'll put a link in the chat here. I don't think this is going to go to everyone. I don't know, but this was a a game on the Amiga where you have a platform where you jump up levels, and when you get to the very end at the top of the level, it actually does fire fireworks. So I figure if we can do a fireworks simulation, that might like a particle simulation, that might be fun for. If we can get it done before midnight my time, then that's like a nice New Year's celebration thing we can do.
Yep.
We'll see where we go to.
And that's about an hour and 10 minutes from now, right?
Yeah, so I think we'll jump onto that first. I don't know. Well, let's just see. I'm not in a fuss to like I'm not like pushing to get something done for a certain time. Let's just see how this thing goes. We're playing around with new things. I don't know how any of this works in terms of cross-platform. So we're gonna have fun and find out. Okay, right. Where was I? So let's see if we can get a share going here. Yeah. Okay. Sorry, everyone. Bear with me. Life is complicated, apparently. Notifications. Okay. Here we go. There we go. That's my own channel now. Okay, that's good. Okay, put that over there. Right. Hopefully.
And while you're all waiting, everybody go subscribe to my channel.
Do it.
And I've got a new video out just minutes ago. Well, it's 2 hours now, but that's some number of minutes. The dinosaurs roamed the earth minutes ago. It's just a hell of a lot of minutes. Like the old things, pennies a day. Yeah, right.
Okay, that's. I think I'm there, and this is riveting content everyone's watching right now.
Yeah, I tell you, I would juggle, but I'm not a juggler, so I'm not doing anything here except watching you type. Oh, watching you stare at a thing that type.
Staring. Yeah, we'll get there. All right. So what I'm going to do, I'm going to make another branch, and then I'll. Bear with me, everyone. I know this is fabulously interesting. Reset. That's what I want to see. Okay. So, a couple of things we'll bring in, and we'll get there. Yeah, that was it. So, okay, let's see if we can bring some. Share screen. Ow. Crap, sorry. Clicking the wrong buttons. Yeah. Who said this sharing stuff was easy? There we go.
There we go, yeah.
I thought I'd also bring this up. Happy New Year in advance. I love this tweet. 23 to 58 coding, 23 to 9 coding. Midnight, Happy New Year, back to coding.
Yeah, that's all of us tonight. Yes.
Yeah, definitely. So let's crack on, I guess, with some coding until that midnight time, and we can stop and celebrate for all of like a minute.
You figured out the multiplier and the offset for the parameters for the tiling?
So that's what I was going to sort of jump into first. So I think what we figured out before, I think I'll go through this. I'm going to reset these changes, and then that'll work. Right. So let's run it, and then people will see where we're at. Those that are catching up, and let's run it on. Okay, so we ran into a bug. The stream was going for quite some time. We ran into a bug for it was displaying It's actually running. It's resolving. Yeah, I'm going to make this wrong button. This one.
Whoosh.
So we've got this custom renderer, and we're trying to draw the tiles. And this is our little map thing that we were drawing, and this is the output that we were expecting, right?
Mm-hmm.
This is the output that we're expecting, and funny enough, we won't get an output, and hopefully we'll be seeing that output in just a second. Come on. No worries. Happy New Year. When it builds.
Oh, I'm logged on to the chat and then with the wrong user ID. See if I can get that
Here
fixed.
we go. Yeah, so this is what we got before. And as we can tell, this is not what we have in the background.
No.
So let's fix a couple things. So we did actually have a blue background before. The reason why it's changed is I changed the data slightly. We'll get into that in just a second. So as we can see, this is off. Now I was trying to work out why it was off, and I think it's the way it was the way we're calculating these cells. We're saying seal to double because, and it turns out that the original tile set is not the width of a power of 2. In fact, it's not an equal width of the number of tiles, which means we're relying on the editor to index things in a certain way, and we have to match that. And it's not a known piece of data. It's not. I didn't see any obvious documentation as to like any sort of warning saying that the tiles sheet is off. Anyway, turns out it's like a few pixels off, and that's caused a rounding error. So our indices that we actually look up inside the layer are wrong, basically. So if we now change this to, I'm trying to remember what it was now. It's probably floor. And then I think there wasn't. Well, I'm just going to go. I can't even remember what it was, and I don't want us to find it right now. But let's go take a quick gander at what it was, because I had it already in there. It was that, yeah. Yeah, so if we do it should be the same. Right, and then it's right. Well, look, we're not going to fight this again now because I've already fixed it. So we were off by 1 on our tile indices because 0 is considered a reserved. As it truncate to double, I was doing as well. So what was tile stride? Yeah, because the output of this is an integer, basically. That's what it's complaining about. Yeah. And again, I wouldn't actually have to do this because we should be able to work with integer values directly. The only reason we couldn't is again because the sheet is off. So let's see how that looks now. Why is it looking no different? This hang on a minute. No. The level data has changed. Maybe that was it. Let me have a quick look. I think so. No. Okay, this is going to bug the hell out of me now. I need to quickly see this. Hang on. We had a tile stride. I was looking up the tile value, which is off by 1. So that's correct. So this is basically saying, because 0 is considered transparent, right? So the indices in the map are 1, but when we calculate the position in the original image, it's calculated from 0. So this is our off by 1 issue. And then, of course, if the value is transparent, then this makes it -1. by the -1 off 0. So if it's less than 0, then it becomes transparent and we don't have to paint it. So that's kind of like the magic there. Why is tile value? Oh yeah, I remember now. Sorry. And then the other issue was our source offset is not. These are actually the tile. This source offset is in tile coordinates, not in pixel coordinates. So that's one of the reasons why we're milling around always around that one graphic and slightly off on each one. So here in this case, we could convert that tile offset to a tile column and tile row instead. And that puts us back to being in a situation where we have working graphics. Right. Let's have a look. Hey, look at that. Yeah.
Yeah.
So, and we have a little dash character, and we have, if we consider this to match, there we go. Now we're only painting the one layer at the moment. Is that right? Yeah. So if we get rid of that, there we go. Now we're painting multiple. Now we're painting multiple layers. Now the background.
The whole thing.
Sorry.
That's the whole thing now. Yeah.
Yeah. So now it was. I noticed that on in the editor here, we can actually add. If I click on like a layer, we can add custom properties. So we can actually add like a color property here to the layer, and we can add all sorts of properties. They're really kind of powerful. So that works as good as a really good sort of level editor and game editor. So we're gonna work on that. We can add objects into the game, give them a pickup score, kind of give all this kind of data to, and we can ingest that and use that data inside the game. So I think the first thing we need to do though is one of those values is the background. So I noticed in here, if we look at the map properties, you actually see a background color. So I've set that in here to this blue, and you can see it in the editor, but we want to see that in the game. So where we load that data at the moment, when the app first starts up, we take to load the exported level.json, which is just us exporting it from the editor here. And then in, where was it? This then interprets that file and decodes it. And at the moment, this was decoding it in kind of like not a great way. This is like just reading the fields directly. It's a bit janky. So I update this to use the proper way. Should we say proper way? And that was just to sort of decode. Let me just make this bigger. Hopefully people can kind of see that. So we now decode the tile width and height for the level layer, the background color as well from the file, and then also decode the fields correctly. I'm going to go back to this commit because there's no point keeping what we're doing right now. It's the same. So that's nice. That's done. And then when it comes to painting it, what we're doing is we're just choosing to paint the background with that color. As simple as that. I'll walk you through this in a second. I also put a visibility on the layers. So each of the layers can have a visibility toggle. And if we export with the visibility turned off, well, we can then see that and hide that layer inside the app, which is quite nice. And then I think finally, I've got a retro gamepad right here.
Ooh.
So I wanted some code to get that working inside the game. So I've added that in there. I'll walk you through that in just a second. And what else here? And all this little bit of code here is doing is picking a color based on what button is pressed on the controller, and then it's rendering the player graphic with that color. So then we can just see if it's if the buttons are working, basically. So all right, so that's where this sort of comes in. Yes, universal support is for Xbox. There is actually what do you call it? What's it called? X input, which is the Xbox controller input, and that already is a great API that exists. But the problem is, it doesn't recognize any game controller. So there's actually a separate API for game controllers, which is separate from the Universal Windows apps X input stuff, which is kind of annoying because it just supports Xbox. So I decided to just wrap that in my own code and bring it in. It's still a valid API. I'll show you in a second. So, all right. So anyway, so that sort of brings us up to date with these changes. Oh, no, it doesn't. So I added a ticker. This allows us, so a ticker in Flutter and Dart is where each frame is a tick, and we get notified when that frame starts, and that's what this sort of like on tick callback count gets called. Here I calculate the elapsed time in and work that in as delta time. So delta time is always going to be a fraction of seconds. So if it was the time between frames was 1/60th of a second, it would be 0.016, 60 milliseconds, no, 0.0016, whatever. But the point here, it would be the fractional amount of a second, right, by doing this division. And this allows us to apply that delta time to all of our steps we do per frame. And it means all graphics are considered constant, like the movement of everything is constant. If you don't do this, what can happen is if you get a frame, let's say it drops a frame and you skip a frame of graphics, what will happen is you're in a count for 1/16th, and now you've done twice that speed. So the character would go fast, slow, fast, slow, fast, slow as it's processing frames in different amounts of time. So this guarantees that there's a steady processing of data. Anyway, runs game tick.
Wait. Where's create ticker?
Create ticker is from the single ticker provider state mixin.
Oh, okay.
That automatically disposes of the ticker in the dispose method. So we just need to start it when we want and stop it. That's going to call game.tick. And then in game.tick, let's bring that up here. All I do in here is I tell it to update the gamepad state. If the gamepad is connected, get the direction from the gamepad. That's now a direction vector, or DV for short. Multiply that by our velocity times the delta time. So in other words, what we're doing is we're taking the direction from the gamepad here. If that's left, then it's like -1, right, +1, so on. We take that, apply that to multiply that unit vector by the velocity of the current player, which is 0.1. Which, by the way, let me just explain. Velocity then, because we're scanning it by delta time, and delta time is in the unit of fractional seconds, that means all velocities are units per second, right? So just kind of like making sure. It means that everything, as long as we treat that, everything's consistent. We could take this one, if this is a big game, then we could take this one step further and actually have a unit class. And then have different types of unit measurements that then can be converted between each other. But so you could have things like milliseconds and other units rather than just fractional parts of a second, depending on how you're trying to work out your numbers. There's different benefits to those things. For example, this very specifically accounts for things like floating point errors. Also, if you know that delta time will roll over eventually, right? So there's some other. If you leave your game running long enough, it will reset. So what you can do is you can put like an upper limit, and as long as the computer knows the upper limit, it just resets it back to 0 and treats that as like a fresh start. So there's a few different ways of dealing with that, and with like a negative time offset, but yeah, doesn't matter right now. Right, anyway. So, all right, and then I'll show you gamepad now. So I'm going to go back to the previous commit. Am I? No, I'm going to break it. Abort. Let's reset this here. I will push this code, and then everyone can have this code after the stream. So I'll push it at the end of the stream. Unless you want to code it. Do people want to code along? If people want to code along, I can push it now, I guess. If anyone else interested. So, right. Anyway, let's get rid of that.
You have to wait for the required 12 seconds.
Yeah, we'll wait for the little lag there. Anyway, so yes, now we've got that code in there. We're gonna stop and start this. Go away. Run that up again. So now we've got the background color coming through from our JSON file and the assets here. It is at the top, and we interpret that as a hex value, which is what it is. the hash will be indicating that it's a color hex value. Yeah, we don't treat all of these parameters, like we don't go specifically loading one, but there's the blue. Wonderful. That works. Here's our dash in the top corner. Just because that's why I set them off at a 0-0 position. And now if I get my controller, which is probably fallen out of sync, it's wireless. Hang on. See if I can get this. There we go. There we go. And I can move the dash around.
Cool.
With the
but it can go through things, right?
And then and then I can change the color of dash based on the particular button I press.
Wow.
Right. So that's just, that now we've got an input, we can do some testing. That's great. We've got a stream of graphics. So I guess like we just need to pick and choose our battles about what we actually want to do next. So there's an aspect of, obviously, we now need to think about, do we want to do the fireworks? Do we think we've got some time? Do we want to do a small particle system?
Yeah.
I want this to be black in the background as well. Let me do that. I'll show you the Gamepad code in just a second. So first of all, I think, I don't know, I'm going to put Gamepad in util here just because it's not really part of game. We got models, so general top level app. Okay. We don't really need to do that anymore. We probably want, so I think we said this before, that when we, he says, oh, no. What happened there? Gamepad is not R because I moved it. Did it break it? No, we're here. Okay. So one of the things we did in the design editor is I put the layer, if I turn off layer 2, you'll see down the bottom of the screen there, that tree disappears. So that's actually in front of the player, right? So what we actually want, well, the reason why we did this is so we can have like a foreground layer. And as we can see here, the player is being drawn. It's all been drawn behind the player. So we want the player to move behind the tree. So all we need to do is during our game render, we're going to say, okay, if this layer, so we need a way of saying, is this a foreground layer? Or in general, we kind of want to go through and do 2 passes, right? So I think this routine is getting a bit more complicated. It's probably better to pull this piece out and have like a render layer function, I think. Yeah, so let's have a paint layer. And what did we call our layer? It was a level layer. And I guess we want a canvas size. So this is going to go for each layer index. So let's do this. Right. So does the level actually know what tile set layer, know what tile set is going to use? Because that, so I never quite got this with the editor. I think I need to look into this a bit more because it does, look, you have like first GID 1, there's the tile set that we're using. It picks out the tile width and height. I don't know what happens when you use I think this is maybe because we only have 1 tile set we're using. If you use multiple tile sets, I think it might be different. And let's stick with the 1. Let's stick with the 1. Make our life easier, not harder. All right, and this is becoming a bit of a pain now because this is like the painter is an artifact of Flutter in the way that we're rendering it with Flutter. It's not really how we want to render it. So now we need to, in rendering a pass, we now need to consider, these parameters and pass them all around is going to get really complicated. We want them as member variables, but not of a painter. So what we want to do, the simplest way to do this is we're going to create a, let's make an engine folder. Actually, that makes sense. Let's change that util folder to engine. So what I'm trying to work out here is just a way of organizing this. So game is going to be all game specific code. So that's going to be the logic of the game, how things interact within the game logic and behavior. Engine will be how we're rendering and interacting with the outside world. And then app is going to be the Flutter specific kind of widgets and that kind of sense of where that is. And then models, obviously models. I think that's kind of a nice separation there. Okay, so given that, what we want to do, we're gonna just organize this slightly, and then we'll get into. Is anyone wants to see anything specific? That's another thing. Like, is anyone interested in a specific area of this, or how to achieve a certain thing, and then we can sort of aim for that as a first go. I don't know. See where we get to. Right. Okay, so engine's also going to have a renderer. So that's what I was trying to get to. Renderer class renderer. Obviously, this is going to have a impact on. It's going to use the Dart UI system for all this rendering. I'm going to do it as UI. What we're looking for, we're going to go for render on a canvas of a certain size. Cool. Now we can have our state. And I guess we could do a, when we initialize with a level, we could make an instance of each. Well, at the moment, a layer doesn't need any state. So probably good to have, probably not worth having an instance of this per, we'll just pull in the function and we'll call it render layer. And as I said, this tile paint now, stride now exists inside the renderer, which makes sense. So our tile, oh, I've lost it. Is it tile paint? That's fine. I can come into the function. And tile size and stride and tile set. So size, set, and stride are all values that we can pre-calculate. So we'll do that in our constructor. All right. So we're going to hit this as an int. Tile set is a image, UI image, and size. Okay. And then we want images, I guess. What was that listing? What was what this asset image is? I can't remember what we called it now. Image assets. Image assets. All right. Okay, so we bring that out. So when we go to render something, I guess we're going to have a renderer with the level data. We'd probably recreate one for each level. Maybe. So let's do level data. Bring it in. Start level. We want some music in the background of the stream. We could do like a little low-level music. Hopefully this is entertaining. Happy New Year, everyone. T-minus 40 minutes, yeah. Right. Okay. So we've got a level coming in. So now render can go over each of the layers in the level and render them. So we're just refactoring here. Just tighten this up. All right. So here we go. Level.
I had to find my Twitch login so I could respond back to some of the comments. I'm glad I have a Twitch login buried somewhere.
Thanks, Randall.
Yep.
All right. So now this is render layer. Okay, that's looking a lot nicer already. A lot cleaner, which is going to help us going forward. All right. So draw background can also go in there. So we want to say draw background, draw layers. Rect is 0 in size. All right, so now we've got draw player. So we'll put this code in a function in there right now, and then we're going to have to come back and go and assess how we want to have an entity system. There's options, many options. I think, to be honest, it's probably not worth us dealing with much. We could probably just do a simple entity list. So anyway, so what we want here, draw player. Canvas size. We could take this one step further and actually have it so that so a nice way of doing an engine would be to do like a visitor pattern. So you actually have your renderer, you say draw this, and then so like a layer would be an entity itself in the system, and then you send the renderer to draw a layer for one of it. It basically means you don't have to hand around canvas and size everywhere, because that's part of the thing that's already knows about how to render stuff. Right. Game, which holds the current state. I'm not sure. So this is interesting, but this is in the wrong place, right?
Oh.
So nothing to do with rendering should actually look at the buttons or control or anything. So I think we're going to take this out here, and we'll go over to our actual game code. And then in here, we can look at the gamepad state. And say, well, first of all, if it's connected, there's no point doing it if it's not connected. So put that there. And then we'll make it null. Right, so my thought here is, oh yeah, no. Hide colors. So we just have, just explain what's going on here. So colors, I'm using colors from material, and it's saying it's not a vector 4, it's not color. So this is because the vector math library has its own set of colors, class. So we want to hide that from here, and that stops the name collision. And now it will say this is not a found class, and then we can import that class from the appropriate place, which is material. And what we can do even better than that right now, because we don't want to use it anywhere else, is we'll just say show colors. This way, we're only importing colors right now. Because again, I don't really want this in here anyway. So we'll want to change the file as well. Right. Oops. Okay. So, and color. Why not? Let's make some room. Okay. So
you could also just told the IDE to narrow it down, right? Just to the things that are actually being used. There's an IDE call for that, I think.
Yeah, probably somewhere.
Yeah.
White.
Something about enhancing show hide.
Let's call it. All right, so now we've got that. The state of pods and everything else, we don't really have entities right now. So if we add entities, happy New Year, Renuka. Your son might like what we're doing here. We're building some game stuff. Yeah, we also want to use Draw Atlas. So that's a good point, actually. Let's bring this, because that was an original comment on the. Let's bring this back into Renderer, and we'll update our tile drawing to use that. Maybe not right now, but because it worked. But to do optimize our tile rendering to use Draw Atlas. Oops. Okay. We don't really need all the parameters. I'll just do this, and that identifies what we need. Okay, so images. I can see us wanting images elsewhere, so let's bring that in, especially during rendering. We'll match that the same way around. Okay. What else do we have? So now we need the player kind of position. This is from game. So this kind of comes back to that whole entity system. So I'll pull game in right now, and we'll render with game. And then what we'll do is we'll then refactor that back out and show you how you solve the problem, right? Because code gets messy if you don't organize it. Right. Why is this not? Oh, it's called Snow Dash Game. Okay. And then this becomes a parameter to our render. And then this can be game pods. And there's a few other little optimizations I can see here, but this will get us back to a rendering state. So we want to draw the background, we want to draw the layers, and then at some point we want to draw the player. Let's put that call in here. This will take us back to where we were. Now, all of this refactoring work was to fix where the player is drawn in terms of layers. So let's get back to that, and then once we solve that, we can move on to the entity system. So, okay, now we have a renderer, and our game screen is pretty empty right now. So we have the painter. So we could do something where we create a instance of renderer. So instead of passing all these things to this, create an instance of render in here. And what did it want? It wanted our game level data, all the rest of that stuff. All right, I think we've got everything. The level is widget.level data. Images, which I've already forgotten. How are we passing it in? Widget.images. Oh, there you go. Done. All right. So now we've got our renderer. During our paint, we want to pass that in. So renderer in game. Render game. Okay. And then based on if that changes. Okay, now back to where we actually want to be. Renderer dot render canvas size game. Okay, so we just basically just extracted all that out and refactored it, but that means we now can get away from this kind of like screen, right? Okay, so it's going to complain right now because we've changed a bunch of stuff. I'm not going to bother with that right now. So are we error free? Yes. Oh yeah, I'll show you the joystick code in just a second. Right.
Errors at no extra charge. Errors are free.
We are error free. Okay, so renderer and inside engine, we'll start doing once this goes through, we'll start doing the entity stuff. Have player, and we could then start adding various entities into the system, have them being created by the level loading, and move them around and all sorts of other jazz. I guess we could start a particle system before. Hey, Christian. So I guess, I know. Oh, I see a bug.
No, not a bug.
Yeah, I thought this might happen, but so let me see if I can get this out. Can you see these like vague lines? Can you see that little line there? It's pretty thin.
Yeah, tiny.
Right. This is because what's happening here is we're getting aliasing on the edges of the rectangles that we're drawing. So the draw image rect is actually doing that. So tile paint, we should be able to set the. We don't need it anti-alias. Well, I don't think that will make a difference, but we'll set to false anyway. It's the filter quality. We'll set to none. All right. Save.
I think I'm going to get yanked away in about 5 minutes, but it'll be fairly short.
I have a feeling that this is like another rounding error, but I'm not going to fuss with it right now, I don't think. I'm pretty sure it is the filter quality. Draw image rect. Yeah. We could try high and to see the opposite effect. I'm pretty sure we don't want it to do any sort of filtering, but.
Are you sure you aren't running into like a half pixel rounding problem?
Well, no, because this actually is 320. This is why I think this might. Oh, high. There we go. This could be a. Could it be that issue?
I've stumbled across half pixel rounding problems before, and it's been annoying because the math.
No, it is that kind of thing. But equally, my numbers here are all integers, right?
Mm-hmm.
So.
But there's still a mapping at some point of these integers down to the raw pixels, and it might be that those are dithering just slightly wrong in the map.
I mean, don't get me wrong. It's entirely possible, and in fact, I could just do this plus offset 0.5, 0.5, and see what comes up. The problem here is this is.
Yeah, you might smear things over.
There you go. Look, it's made it worse, right?
Okay.
Minus 0.5. I don't think we're going to be seeing the effect that is expected. Hang on.
Minus not legal.
It's because of the and. We're doing it in the wrong. I mean, it is working and it isn't working at the same time. I mean, this is not the solution.
No. This is hat. This is serious.
I mean, we could do it. It's not, but it's not guaranteed to work in every situation. This
is square peg. Darn it, fit into that round hole.
Exactly. Why I got? Oh wait, there's source. Yeah, no. So what I want to do is also put it in the wrong place. Size and reduce size down by that amount. Can I do that? Minus size. That's
okay. I got visitors, so I'll probably get yanked away any second.
No worries. You're going to be back a little bit though, right?
Yeah. Whatever it is, it'll be short.
Well, guess I'll see you in a short while. If I can figure out why I haven't done this. Tile size .dy, right. Wait, what have I done? I have a bracket in the wrong place. I know I do. There it is. No. Oh, goodness me.
Good thing you're not coding in Lisp.
Right. What do we have here? We've got that. And the size. The size is going to be the tile size. I think it's width minus. Yeah. Right. Oh, extra comma. It's just that. There we go. Okay. Let's see. I mean, it still doesn't really solve the problem. I can still see it in a few places. It's not worth the hassle. We're going to take it off. Like, we'll solve that a different way later. In fact, I think Draw Atlas is going to be our friend in that regard, in the way that it behaves. Undo. Let's take us back. It's enough fiddling around with this. Right. Okay, where are we? Save. Okay, so we'll carry on. Okay, so what now? So we want to get, so let's move Dash. Come on. There we go. Move Dash. Okay, so we want him to appear behind the tree here. And this is kind of where we got to. So what's happening right now is we say draw layers, draw the player. What we want to do is draw all the background layers and then all the foreground layers in the order that they're inside the level editor. We could just denote, okay, layer by name and say, okay, only draw the player after layer 1. But then if we want to reorganize the layers and do something a bit more nicer inside the editor, that would be more difficult, especially on a per level by level basis. If we want to maybe put 5 in the background, 5 in the foreground, or change the way we want to do the graphics. So what's probably easier is inside the level properties, we'll add a property, a flag. Let's do it a Boolean. And we'll say foreground, foreground true false. We could also have is there an enum kind of thing? I think foreground, maybe, yeah. So each layer has a foreground flag, and if it's true, it's a foreground layer, which this is the tree one. And then the background layer is, we'll add that property, but it'll be unticked, so it's false. Same for the very, very background one here. All right, so if I save that, how do we interpret that? Export as level JSON. Okay, so let's go look at level JSON to see if our flag's in there somewhere. Should be. Here we go. Properties, foreground, bool, false. Lovely. All right, so let's go to our model. We need a way of interpreting that data. So the structure is on the right, and we want to interpret that data. So, all right, so we're down here. We've got our level model here. each property has a name, type, and value. So do we?
So you're kind of
We
inventing.
care that much about the types right now because the type is also we also already know the type by its. I mean, let's add another property here. What other types are there? Yeah, so color and file.
Well, you're sort of inventing the z-axis. Do you want to just start calling it the z-axis?
No.
Okay.
We can do negatives and no, because we already have the ordering provides the z.
Sure. Okay.
No.
But I mean, in terms of whether the bird is z level 3 versus 2 or 4, and
let's do this.
Like
let's just
that.
do a map of string to dynamic properties, and then because this is very dynamic, we could have a bool foreground properties foreground, something like that. Oh my goodness me! Right, so yeah, and then up here, properties can then be JSON properties as map, and then we want to interpret that input. So we'll map each entry to each element. And then so we can actually say map dot from entries, and we want an iterable of entries, which is what we'll get back from our little map here. That's what I'll return. So we want to send a map entry. So key is.
It always takes so much work to come back from JSON with its dynamic properties.
We can use. So what we're not doing right now is not using the code generations for this kind of stuff.
Yeah.
And we could go that route, but I don't want to waste the time right now doing code generation. It's just a known problem. Let's concentrate on the game, and we can come back and tie this up later.
It's just I see this all the time as I'm patrolling the socials, though. People are always frustrated with, well, I can just do this by boom, boom, boom in JSON. Why is it so hard in Dart? And it's Dart's strongly typed.
I mean, this would be the same in any language. It's not. It's like JSON is dynamically typed. It's not strongly typed.
It's not a problem in JavaScript because JavaScript, it just drops right in. It's already
but then what happens? You get runtime issues, right? You suddenly change the JSON, and then suddenly everything just breaks randomly. You don't know why it broke. It doesn't show an error.
I'm totally agreeing with you. I'm just saying this is the thing I keep seeing a lot.
Oh yeah, I agree as well.
It's just huge.
Talking for the audience.
Right? Well, because it's trickier. You're coming into from anything goes a laissez-faire to this has to be an int. That's not anything you can restrict in JSON. Well, you can with JSON schemas, but let's not go into there too.
Okay, so let's call that entry. Okay, so this is throwing us an error because we need to be saying that we're returning a map entry of type string to dynamic. I believe. Yeah. Let's see. What's the problem here? Comment something like string. Oh, hang on a minute. Okay, and then this one's map of dynamic to dynamic, which says not a map of dynamic to dynamic. It should be getting its type from KV. So what is the problem here? We have a typing issue. Come on. What? Oh, I'm an idiot. Am I an idiot? I think I'm an idiot. It's not. It's a list, isn't it? Here we go. Take a look. It's a list of properties. Yes. Oh, each one's a map. That's my bad. Right. All right, that's better. So we should be able to get rid of that now because. Yeah. Okay. Cool. Cool. Tied that up. Okay, so so we're back to where we were. So now we've got the properties coming through. We've got a foreground flag. Let's try and interpret that in our renderer. So what we want to say is draw background layers. And so instead of filtering around each layer index and getting that index out, we don't need the layer index anymore. We can just say final layer in level.layers where the layer foreground is equal to false. And we can even say and layer visible. There you go. We can get rid of that and continue then. Is there a nice way of laying this out? Probably not. Ah, that's not too bad actually. Let's do that. All right, so now we have our background layers. We then draw the player, and we want to draw foreground layers. Let's do foreground and not foreground. All right. So see what happens. Restart. Okay, controller. I need to work out if I can change the timeout of this controller. It's kind of annoying for the moment. Maybe I should plug it in. All right, let's see. Do I go behind the tree?
Oh, yay!
My God, it worked.
Ship it.
It's ready to ship.
Yes.
No, I even go behind the floor. No, this is the point. So now I'm going behind the tree because that's now considered a foreground graphic. Yep. And we can put as many as we want on there. So that's good. That's a good first step. All right. What's next? Let's commit that.
Cool.
And then we can see what we want next want to tackle. So we have the foreground layer stuff. Did I save this? Let's make sure we save that. I want that background to be black. Do that as well. Oh yeah, I want to show you the Gamepad code as well.
Yep.
Just a second, because people. Oh yeah, did we still have our colors? Yeah, that still works. Cool.
Well, I can hear my relatives in the other room, but I haven't come and knocked on my door yet. So I guess maybe the food's not ready yet. I guess I'm stuck here until that happens. Not stuck.
I don't know if I want to push this tiled session. I might leave that where it is. But... All right, let's do updated to you. Let's do pulled out renderer and updated to support foreground layers. Now, going to the Gamepad code, just for people who want to understand how this works. So this only supports Windows right now. We can add support for other. Obviously, the game itself will compile on any platform, but the Gamepad stuff is Windows only. So at the moment, it would crash, or actually wouldn't crash. It would just, would it? It probably just would throw an exception for the Gamepad stuff at the moment. But we could obviously in there say, oh, only if it's platform Windows, use this. If it's Mac, do that. We can do that option. But right now, this is how it works. So in the Windows Multimedia Library, that's winmm.dll, there's two functions. One is called get joypad, get joy num devs, basically get the number of joypad devices or joystick devices, and then get the position information, extended position information from that joystick. So this is us looking up those two functions, and then when I create this Gamepad class, we have a current state of it, and we can go get the device count. The ID is just the index into that device count, right? So the first one connected to 0, the next one is 1, 2, 3, so on. And when we go to update the state, we allocate one of these structures, joy info ex. We set up the flags that we want from the operating system. We're asking it where we wanted to return the X, the Y, and then the buttons. All of this, by the way, is just in the Windows documentation. Like here, you can see here, I went to the Windows SDK, and just read the bit. It tells you what to do to get the information. I did it in Dart, and I got the information back. Just follow the guide. So here, I call the function. If we don't get an error back, then great, we got a state. We want to update the state. Else, we got an error. So the joypad is considered disconnected. And we always make sure that we free the memory that we allocated. That's why it's a finally. So I divide here. So this gets the X and Y position is returned back as a integer number, and we divide it by whatever the maximum was that it's using. This gets us a range of, I think, 0 to 1, and then 0 to 2. I forget. Anyway, -1 off it makes it centered. So now we have a -1 to +1 number, or is it -0.5 to +0.5? I forget. Because the joystick here is a joypad and I want a D-pad, I round it to double. That way we snap to any of the extremes. We don't actually have fractional amounts of the joystick can be moved, like maybe to do acceleration. You could do that if you want to. Probably shouldn't be in here, and this could be in what's Gamepad is supposed to be meant for D-pad. Whatever. Anyway, so as I note in here that there's actually a function get device caps. If we call that, we can get these values, so we don't have to do this calculation ourselves. But this is good enough. And then the actual game state, we can grab our unit vector based on the X and Y values, and then to test each of the buttons on this controller is a different bit position in the buttons. All right, and this allows us to test it. So these are the conditions for the various buttons on the control: start, select, left trigger, right trigger, X, Y, Z, so on. And then the rest of this is just the Windows API constants, Win32 constants, and the structure. That's it. So
cool.
What, 180 lines? It's quite a nice little joypad thing. It allows us to interface with the operating system. All right, so now we have our game moving around. I guess there's a couple of things. Once we get, you want to head off, do you? Have you?
No, nobody's called me yet. I'm waiting.
Right. So I guess the first thing we want to do is if we move the player into an entity system. If we make, so we can make, maybe we could color red dashes as enemies right now, just as like a, we could have like angry dashes moving like this backwards and forwards, right?
Wow. Yeah.
And then if the player, then we could do collision detection on the player touching one of those.
Right.
So let's make a little list of what we actually need to accomplish. And then we can then decide on what we want to tackle when. So entity system. So something that allows us to, but for those that don't understand what I'm talking about, is it called an EDS? Some other entity descriptors, entity. I know there's a name for it, and I can't for the life of me remember what it's called. Hang on. Let me look it up. Entity Component System, ECS, is the common name used for it. Anyway, so we want a entity system, something we can control with, and then we're talking about a particle system. So for those that don't know, particles are like used for special effects, like something that manages flames or explosions, that kind of thing. Is that the Kevin Moore that we know? Also, Kevin Moore's around.
Yep.
Entity system, particle system. Okay, so what else we want? We want basic AI. We need gravity and physics. By the way, for those that are curious, we don't have to always code this ourselves. There's the whole idea of this. What is the challenge in doing this yourself? There's Flame. There's some other great libraries that already do a bunch of this stuff for us.
Right.
We can go use those. This point was not to use a library. The point of this was, what does it take to do something like this from scratch, and what is really involved? At the moment, you can actually achieve quite a lot with a little limited amount of code. Yeah, no worries, Kevin. It's great to see you. Hang on, just for those that don't know, this is Kevin Moore from the Dart team, Flutter Dart team. Yeah. Okay, so I think if we do entities, we could then lead up. Okay. Do we want to do like a little fireworks effect and do particles first? Okay, here's the question. Particles, little fireworks thing for New Year's.
Can you do the fireworks thing in 2 minutes? Because you only have 2 minutes, right?
Yeah, I kind of went off on the tangent on the other stuff because I was doing no, we won't, but we could do it soon afterwards. I mean, it's
for the
it's New Year's in some other time zone,
It is. It'll be New Year's in about an hour on in Portugal and Canary Islands, I think.
I'm hearing all the fireworks going off outside.
Yeah.
So we got particle system. I kind of want to, if we do the entity system first, we could then add some basic like collision detection and gravity.
Right. Yeah.
And then based on that, we could then add like firing, stuff out, becomes new entities like bullets. And then those can then hit the enemies. And then you've got your basic game going, right? You've got like things moving around, you can shoot stuff, boom, done.
Sure.
Yeah. All right. So I guess we can we'll do
just keep coding.
Just keep coding.
Goes right.
All right. So I think we're in a good position right now. Let's. Oh yeah, I just realized like tile size.
I'm gonna pop out for a second just to go ask them what the
worries.
Looks like.
Can multiply by size. That's annoying. Really? Can't do that? It must be. I suppose you can multiply by double, but that will apply to the X and the Y. Yeah, that kind of sucks. Why is it not operator multiplied by another offset base? That would be helpful. Time for a PR. Not right now. But... All right. Let's just do it in here. Times width, height. We don't really need the tile. And then this can come back to source offset. All right. And then we'll make a destination offset. Just want to tie this up briefly. This gives us maximum flexibility in terms of, at the moment, our tile set is 32 by 32. We might do a 16 by 16 or have multiple layers, and each layer has a different tile size. Who knows, right? So good to just get rid of magical values and parameterize things where possible. Obviously not to the nth degree, but this is quite practical what we're doing here. All right, so we get our source, destination, tile set, copy of source. That's a lot nicer, right? Yes. All right, so what's next? Entity system, that's what I'm talking about, right? So what is an entity and what is this relationship? Entity.com. So class entity. What do we want inside this class? I guess each entity can have its own ID. A string ID. Sure. So we can do find entity. Do we want? We kind of want child. Well, okay. Let's just consider what we actually got going on right now. We want a position and velocity, and what else do we want on each thing? They may have velocity of 0. They don't move. They're static, but interesting. Oh, final. What do we do final? Oh, it's because that, yeah. Position velocity. I feel like I want something else there. Type. I guess we can have a type. ID and type. Maybe that's helpful. Maybe we're going too far. Type. All right. So do we want them to be listenable in some fashion? I don't think so right now. If we do need to listen, pay attention to a particular object, then we can or add that feature then. All right, so what's this? This is because they're not 0 yet. Okay. Okay, so our basic entity. I'm sure we could actually saying that we could. We want a update function. So we can make this an abstract class. And a render canvas size. think that's enough for now. Okay, so our game is going to have a sort of level. Obviously, it doesn't quite work right now. Why do we have level in here? Do we actually use level down? I guess we need the current level, but game is probably going to persist more than level. I think the whole reason for this is just because the way we load the data in right now. So look, game screen. Because I mean, we don't really have a menu screen or anything that at that point. So I think we'll pass level in. Hey James, Happy New Year. Yeah. Okay. All right, we'll leave level data in there for the moment, but obviously the notion here is that a game is going to be long-lived, where more than one level, basically. Let's put some music on in the background, shall we? Is there something? Hopefully that's a little bit nicer. Right. All right, so let's get our entities in here, and when we create a game, a game level is basically the same thing right this minute because we only have one level, but then we'll have to separate those concepts off. So we'll say entities. Entities. Right. I mean, again, the concept of a game itself could be part of the engine. And then the game-specific code stays in here. That also might be nice. So we do something like game Dart, which is abstract, that contains some of the basis of what we're just doing. So that can have a set of entities in it. And there's a way of initializing and disposing. Also can notify. Let's bring in change info from foundation. Okay, entity in. Okay, what else do we want? Tick. And okay. And what do we actually want this to do? Well, tick, we want it to notify this is the end of its doing its thing, and we want to loop over each of the entities. Yeah, final entity in entities. Now we want to do a list dot of, and the reason for that is this means that during the processing of an entity, we can actually remove from the entities list without it having a current modification issue. What I mean by that is if you're looping over a list and you're halfway through, and then you delete something from this side of the list, does it carry on from this point, or does it go one back and carry on like editing a list, changing the indices whilst you're iterating over it is normally a bad idea in most programming languages. So list of kind of just essentially makes a copy of the references to the elements of the list so that we can just iterate over them without a problem. Okay. Entity dot. Yeah. Update. That's it. And then we'll pass delta time to the update function. And that way, every entity in the system can do that. Oh, yeah, that's a good point. Are we still rendering layers or entities? So this is what's so vague about this. Is it Matt? Is the idea of an entity is very vague. It's just something that exists inside the game world that can be updated on every tick of the ticker. How you use those entities is down to actually how you build your game. So there's two halves to this. One half is the engine we're trying to keep as abstract as possible and basic as possible, and then our implementation can then be as complicated as it needs to be. Does that make any sense? Okay, so this is going to go up. I don't know if it needs to. We also probably want an event system. Yeah. Let's put that in here as well, because I know we're going to need that. Yeah. What do we call this? What's it saying? Event. Abstract class event. I really don't like having strings to type. I just don't think there's a nice way of doing this without being too vague. Let's abstract. Let's just put all the event stuff in here. So what I'm thinking, basically, let me explain what I'm thinking. We need a way of normally an event will occur in the system, right? And that might cause something to happen. I'll give an example of what happens in game systems. Let's say let's take a door and a key. So you can do a couple of things, right? No, it's probably a bad idea. Try to think of a good example. No, we're going too far. We'll come back to events. I don't want to distract from what we're doing. All right, so this is basic enough. So we have a list of entities. We knit, dispose. We have a game. We can notify, and then our game, our specific implementation of game. Let's bring that up. Extends game. All right. And then when we start entities, add, now we can add player, right? So inside our actual game, we can now create a class player, extends entity. Oops. And this is what I was coming back to earlier. So type, we can fix that. So it should be super. could look at the object type. That actually might be better than having a string type, isn't that? ID is definitely required. All right, let's go back to here. So in this case, we only have one player, so we'll do super ID player, just so we can identify it. Oops. And I guess an entity could also have a toString, just to identify it nicely. So in this case, we want the runtime type, followed by its ID, and then we'll do its position and velocity. I think it's enough to pick it up. Okay, so it's in debugging. Update. I'm just thinking like we can just have things automatically update based on their velocity and everything else. I suppose the default can do that. We don't have to call the default. Yeah, okay, let's do that. So position plus equals velocity times delta time. That's your kind of basic, move something, right? So based on the amount of time, the time slice that we're having per tick, we're going to apply that to our velocity, which is in per seconds, which now we know how much we've moved in this, and then we adjust our position by that amount, thus updating the object on the screen. Okay.
Okay, what I missed? What I miss?
Good question. I don't know where I left off. So I started doing entity stuff. So here's an entity. It has an ID. I removed type because we used the type of the object. There's a position. Every entity has a position and velocity, and then update function will update that position and velocity. Render obviously needs to be implemented per object, and then we have a toString just to make things nicer. Our base game implementation is just that. Per tick, it will go and update each of the entities. And we have an empty disposer net right now, just something that can be overridden as required. Yeah, and we have a list of entities, right? So we can extend. Actually, let's make this private. I shall make you private. I do not care. And then what we'll do is we'll add some other methods of management in here. Yeah, we'll have void add entity and remove entity. So remove returns a Boolean if it's been removed. So we only want to notify if it has. Add. You can always add a duplicate because it's not a set. Do we care about that? I think we do. This should probably be a set, right?
I like that for sets. that add and remove return a bool about whether they were successful or not, because that's a nice side effect that you can take advantage of.
Totally. Well, like now, if I add it, then I'm only
Yeah, exactly.
Yeah, I'm. This is wrong. This should be named, and it's required.
I used it once to do deduping, but keeping in the original order as much as possible. And it does that by trying to add. And if it doesn't succeed in adding, it just leaves that element out of the ultimate list. Pretty quick, pretty clever.
So here's the next thing. If we add an entity to our system, if we add an entity to our list, we need to, like, we either have. Let me get back to the actual problem I'm trying to solve. And that is, we're going to need to know, the entity's going to need to know what game it's part of. So, like, let's say, for example, the player during the output function goes, the fire button pressed, so I need to create a bullet. So that bullet needs to be then added to the entities list, right? So there always needs to be a way of getting back to the main game class. So I think what we're going to do is we're going to use part and part of, right? So we'll say part is entity. And then entity is going to be part of game. And there's a reason for that, which you're about to see, hopefully. Back in here. Okay, so now we've linked those two things with part and part of, it means we can use the internal things from each class. So in this case, we can now make a private function inside of here. We can now have game underscore game as a private member, so it can't be set anywhere but this class, for example. And then we can have a getter for that if we want to. So we can read game. Something like that. All right, so now we've got this private member, which is going to be nullable at the beginning. That's fine. Then when we add something to our, if it's successfully added, then entities game is this. So we're now taking ownership of the entity. And then when we remove an entity, if it's successful, then that entity's game is set back to null. Right? So that's just kind of like us allowing a game to essentially, when you add or remove to a game, it overrides the owning game of the entity. All right, so now we've got that kind of relationship between the two. I think there's maybe an aspect here which is we do something a bit generic just so we can access things easier. So G extends game, and then this can become G and G because we have a specific game type, so we don't want to have to do as and all this kind of funky stuff. So now we've done that. Theory goes, we don't really care about that in here. So now player is an entity of what game? It is, what do we call game class? Snow Dash game. There we go. Oh, and the Snow Dash game itself extends game. No, it does. And we want to add entity player. What is wrong with this picture? We've got a lot of things going on here. Apologies. Doing some quite a bit of refactoring. It's a G extends game, but that's fine. And player isn't a type. Is that because? Why would it be 10? That's okay. Well, let's. I don't know why it's saying that, but let's move some stuff around here, and then we can come back to it. So, our initial player position, velocity, and everything else. So, maybe we need a init function on each. That sounds like a good idea, Simon. So I'm going to have player color. I'm just doing the same thing we did over. Right, so now we have a player color. That can be private. Now we have a render function here. Update based on the gamepad. So updating the gamepad state, having gamepad be part of this particular game, same as level. And then when a tick occurs, we update our state. And then we want to call the super tick. That's the bit that loops around. If I follow this, that's the bit that loops around and goes to the entities. So now this piece about being connected is out here. This is how simple our sort of top-level game becomes. Say hello to Ari from me and Happy New Year. Thanks. Okay, so now player color comes out, our position, and 0.1 comes out. So this ends up being what game is. Really, really basic right now. So we add a player, and then we update the gamepad when it loops. And then the player, when we get an update. So entity of Snow Dash game can now be a base in here. That sounds like a good idea, doesn't it? Game entity. Abstract game entity extends this time. The reason for this is we're going to have a lot in this game that follows this pattern. So why is it Snow Dash game isn't a type?
What?
So it can't be used as a type argument. It is a type.
Where's it defined?
Right. It's right. It's saying Snow Dash game is not a type.
Oh, right. I see that. Yeah.
It is a type. Though. I can see it right there. It's a type.
Is it not imported into the other file?
No, because this is any G that extends a game.
Okay.
And Snow Dash game extends game, and it's the same class. It's definitely the same.
So.
There's definitely no problem there.
Oh, that's a little weird. Restart your analyzer.
I think it's probably that. Yeah, it's probably got confused. All my renaming and everything in some fashion.
Or as Doctor Who would say, reverse the polarity.
Yeah, indeed. Reverse the polarity of the neutron flow.
That's right.
Right. So when we add, we're gonna init. So, yeah, that makes sense. So game is set. Or actually saying that, maybe it's first render. That might make more sense actually from a gaming perspective. So we have tick. Okay, so I think I'm going to rename this to update. Sorry, there's a lot going on here. So our game screen when we do a tick, it updates. When we go to do a paint, it's happening at the reason why this is that we separate these two things off is that paint can happen independent of our ticks. So we might have a good example of this. We might have our logic that does physics running maybe many hundreds of times a second, whereas our rendering only happens 60 times a second, or some other difference between those two. This can also stop things like clipping through walls and some other issues that you get in games. So you update like this is the kind of thing you update the physics at twice the rate you would update the graphics. Put that to one side. So render, we actually want this to call render on the game. At the moment, our renderer is very much hard coded to this kind of notion of layers, which is fine for the moment. This is just the game that we're doing. Renderer is really part engine at this point. Not if it's this, but it's fine for what we're doing. But what I do want to do is say, okay, given the size. I need to think about this a little bit. Should we care about? Let me give you an example here. What I'm talking about here, Randall, where I'm trying to go to.
Sure. Yeah.
So when we add the player, we want to position that player. Let's say we want to position that player on the screen somewhere.
Right.
And it has to be once we know the size. We either treat our positions as like. I know what the problem is. Okay, so let me explain where I'm going to on this one. We have a fixed playfield size, and our position of the player is in. We have a world. We have this notion of what do we call them? Transforms, spaces.
Like the tile sizes.
What I'm trying to say is, so for example, anything relative to the object you're talking about is normally called local space, right?
Mm-hmm.
Local transform. Mm-hmm. And then you have a global transform or world transform, which is in coordinate system of the world.
Right.
So you fire a bullet, and that might be relative to the world. Whereas if you hold a sword, your character holds a sword, that's probably relative to the player. Yeah. So that way the sword moves with the player. For one of the better word right now.
Sure.
So when we position the player at the start of level, it's not going to be center on the screen, but I can see times when we want to perhaps have example. Let's say we want to show game over message on the screen. We either know that we need to know the playfield size, like the size of what's visible on the screen, to be able to position something centered, especially if we want to change resolutions and things. So I have this notion in my head that you add an entity to the game, and then it's not until its first render that it gets initialized, but then it still needs to get updated before that. So now my head is like in two places around how this can be done. I think I will hard code some numbers and come back to this problem. I don't want to stick on one problem for too long right now. Let's get some movement on it. So, and right now, game init takes place. It's a game adds entity, calls a init, and init can then call, the normal init can then call init on all the entities. That gives all the entities a chance to do something. Now that they've all been added. Okay, yeah. Okay, and then the reason for doing that game entity is now Gamepad, which we know is an object inside of our game. We can now expose that here. And that can be game.gamepad. Oops. Now, why? Oh, this is just annoying me now. extends. Try. Oh, wait, what? Are you telling me because no, I just didn't import it. I just didn't import it. That's what the problem was.
I thought you said. I thought I asked you, did you import it? And you said no.
Right. Okay. All right. So now we've done this. We have a game entity. Maybe we call it Snow Dash entity.
Didn't your IDE tell you just to fix it by importing it?
Probably. Yeah, it did, but I wasn't paying attention apparently. Okay. So now we have a Snow Dash entity for the player. This is better. Nice. Okay. So init. So when the player gets added, it initializes, and we're going to set position to. So we can actually load this from the level, right? At this point. But we'll just hard code these values right now. Let's put a little to do load position from level data. Okay, and then when we update, if the gamepad is connected and state, then we do position plus equals based on our velocity. And then we also can update our player color. Again, this is just the whole player color thing is just us a test right now, right? So let's do it. So we'll mark that in here. To do just testing gamepad input. Okay, so now we've done that. Okay, so now we get down to render. Now we get into the good stuff. Let's go back to our paint. Was it our renderer? We have this render player function. Well, this comes out of here now and moves into the player object itself. And we're going to need a few more things. So images, I think, is something that should be accessible from the game. And obviously this is player color now. And position, that's local. So images, that works out. All right, so let's add in our entity. We want a image assets images getter. I can go to game.images and no, that's not in here because that's specific to our implementation. Where's our game entity? Okay, and a Snow Dash game has level data and final images. Images level data, that's about right. Level data images. All right, we'll do the other way around. Feel free to ask questions, anyone. If you're
for them, I'm not seeing anything.
We probably want Gamepad. It's late. Okay. So net, okay, getting this super net, but we're getting there. Right. Okay, so player. has access to images. Great. That means all objects in the game has access to images for rendering. Great. Well, that's what we're going to get to next. So, so now,
how are you going to render that bird?
Okay, so now we're stuck. Right. So, as I said before, the renderer isn't. Ideally, the renderer should just render entities. So when the game starts up, we go add a background, add this layer, add that thing, and they're all in the entity system. So if you wanted to move an object, let's say we wanted to change the Z depth of these objects on our game, we could do that by moving them in the entity system. The order in which they are in the entity system becomes their Z.
Right.
There's other ways that you can do. If we had currently we have a list of entities. If we're to have a tree of entities, that is, each entity has children, which normally we'll get to after this. We'll get there eventually. Then the relationship between the Z depth becomes one of like breadth first rather than depth first, or whatever. I can't remember, but either way around. Anyway, so we're not going to right now. We just need to identify the player object specifically, or we just say render all entities at this point between these sets of layers, which I think we'll do right now. But then I think we could then do a layer entity and add the layers, and that way when we load the game, we're adding the layers to the screen. And that kind of makes sense because then the renderer becomes one of this whole layer stuff goes into the actual layer entity. Anyway, let's do this first of all. Right, so we need to do game.render. No, render canvas size. Did I not make a render function? I thought I did. Apparently, I did not. Game. I did not. All right. Time to do that. Canvas. It's me. Canvas size. That's going to call render. Okay, so now render on the game. We'll go through and render all the elements. Good. Draw player, other game entities. So all of that. All right, let's see. We are okay. Are we? Let's ignore that in this file. And don't print you are right. We want to print that for the moment. Don't want that. I want to. Where are we now? So no more warnings. That's good. No more errors. Let's do a hot restart and see if we broke something. Is that from before? That's from before. Restart. Let's make sure. Okay. Does it still work? Now I've reorged all the code around. Yay. And it goes behind the tree? It does.
It does go behind the tree, yeah.
So after all that, we now have an entity system. It does exactly what it did before. But we have a great organization. So now I can cross it off my list. So, all right. What we got here? Do you hear music in the background, Randall?
I hear a tiny bit of music, yes.
Yes. Okay. I did put a little bit of music on in the background.
Did my what? Sorry?
Is that too loud?
It's louder. It's not too loud yet. I guess if you talk your normal voice, it's probably okay.
Okay. Okay, let's have a. Do we want to do you want to keep going? How long are we going for? 2 hours. Wow, that just zipped past. Let's push this entity stuff.
You work on the fireworks.
I kind of want to work on the fireworks. So we'll kind of work on a particle system now. We've got entities.
Yep.
I also think that there's room for collision detection as well. Let's add entity system.
So if anyone's playing along at home, you're basically building Flame one step at a time.
not well. I guess you could say that, but this isn't really about making. It's about learning, right? It's about doing these things.
Of course, I'm not saying it's a bad track. I'm just saying that it's like if people have ever wondered what Flame is doing for you,
and the reasons why, and why these things are called these things, right?
Yeah. It's all of this. It's all of this. But
Okay,
it's good stuff to know. Because it actually can apply in other ways too, because you could be talking about orchestrated sets of processes pushing stuff through pipelines.
Yeah.
That would require similar sorts of analyses of how this is happening ahead of that, and now they're coordinating, and now they're depending on each other or whatever. It's one of
those interesting things. I think people, when the game's a good example of this.
Yeah.
Most people, most developers, right? Like you start building a game, you think about the positions of these things on the screen as like one whole. Sorry, the disassociation of state to UI is something that we know from Flutter, right? This is firsthand. Yeah. This is what you want, but this is always how games have worked, right? Let's say for a long time. This kind of notion that where some it's a remarkable thing. You just have to think about all those AAA titles that people are playing now. That all the positions of all those players and all the stuff that you see in the scene, all the positions of the trees and buildings and everything is all represented by data in the system. Yep. People see you see the visuals and you get sort of overridden in your mind that this exists as a digital world, right? It's not really there. It's not really reality in any way. Even though you're moving your player or your person around this world, you get sucked into that game, hopefully, in that way. But really, it's an association of data like we're doing right now, entities in this game, or we could call game world, right? It's like entities in this world. So it's about. No, it's not been a long time that you actually go and say, you don't look at the screen and go, okay, where is this pixel? Okay, the player's there, right? That has nothing to the relationship on what you see on the screen is the rendering, is the visual representation of what the game state is. Exactly the way that you should be building apps, right? Like you have your state of your app right now and what you see on the screen for the app. No different whatsoever. The way you approach it, obviously, is, but in essence, it's no different, right? Like you might have an input manager, right? Or repositories, and all the same kind of thing. They just name something different.
Yeah.
All right. Should we have a little break? Should we have a brief 5-minute interlude, and then we'll carry on?
If you need a break, I just came back from my break, so I'm good to sit here and chat with the audience for a bit or two, and I can answer questions while you're
free to do that. I will be back shortly.
Yeah, I'll be here. I'm still here. I'm not going anywhere. Oh, he left the music going. Cool. Any questions? Let's see. I'm watching the master chat, and then I also have to watch the Twitch chat as a separate chat now. So I've got 4 windows on my tiny little single MacBook window, trying to all work that out. I was hoping that there would be something in the Macintosh world that would let me use my iPhone as even a second tiny screen, so I could put things over there. And you know, that's trivial in the Linux world. I know you just put an X display on it and you're done. But in the Mac world, apparently it's jumping across some incredibly intense devices or something. I don't know the whole thing there. Let's see. I could answer a little bit about working with Leo earlier. Somebody was asking me about that. That was fun. I met Leo Laporte on a cruise. He had not really understood my role with the cruising. My friend, yeah, hi, Metaphysical Mind. I was Neil's, Captain Neil, we call him, assistant on the first 60, 70, 80 cruises or so. And so I was running around kind of setting things up and doing production work in exchange for free cruises. So that was really nice. And so on this particular cruise that Leo came on, we were sitting at what they were calling the ingenious bars, because they couldn't use genius bar, so it was like the ingenious bars, we call them, or something like that. I forget what the exact name there, but so I'm sitting across from Leo, and he says, so what brings you here? And I said, well, I was originally on the first cruise, which was a Pearl cruise, and so you know, and I was I was the first instructor on the first cruise, and that was, you know, 40, 50 cruises ago. And he went, wait a second, you're Randall Schwartz? I said, yeah. And he said, I've got your Learning Pearl on my shelf right now. I'm reading it. And he said, he says, I have such respect for your writing. And I go, dude, I've got respect for everything you're doing with Twit and everything like that. It's just been incredible. And so we had this mutual admiration society going on for a bit there. And then I asked him why I hadn't been on Floss Weekly yet as a guest. And he said, oh, we can fix that right away. And then he and Chris and I had a conversation on Floss Weekly number 9. And then when Chris left, the show went into hiatus for a bit. Chris DeBona, who was the former open source coordinator at Google, had been the co-host and co-creator of the show. And so Chris left, and then I asked Leo, I was on his TV show up in Vancouver, BC. He asked me what, you know, I asked him, why is Floss Weekly stopped? And he said, well, because Chris is gone, and I don't really know big people in the open source community. I go, well, I do. I know lots of people from going to conferences. If I brought you a guest, could I co-host it with you while we're interviewing the guests? He says, oh yeah, bring me all the guests you want. You can go ahead and start filling the pipe. And so starting at episode, I think it was 13, I took over filling the pipe, and that made me co-host for about a year or two. And then finally Leo said, looks like you got it all handled, and made me the showrunner. And then I ran the show for 12 years more after that. So I was on the show for 13 years total. And then I semi-retired out of there. 5 hours a week is a lot to commit to a show. I mean, we do almost the same doing the hump day stuff on Wednesdays now, but it's a lot to put into a show. But it made me famous, which was nice. I was already famous for Pearl, but this made me famous for something entirely different. And now Dart and Flutter have made me famous in my own way. So yeah, it's been it was really good. As of 2 weeks ago, Floss Weekly left the Twit network and is now on the Hackaday network. I'm actually going to be a guest there on the 9th, I think it is, of January. So you can tune into the new Floss Weekly series taken over by Jonathan Bennett, who was one of my co-hosts for many years and had already had his own websites and small podcasts for his stuff. And so it was kind of great to have him on and just continue the namesake. So that's really nice. I'll be happened. Chuck Helbiach. I don't know if I have that. Yeah. Yeah. Leo's a good guy, though. Yeah. Leo, very gracious to carry my show, even though I wasn't anywhere near paying my bills, because there just weren't a lot of advertisers that would pump onto Plus Weekly, and it didn't have the huge reach that the rest of the shows had. It had about 20,000 downloads, as opposed to, say, something like the main Twitch show, I think, was 200,000 downloads. So it was quite a difference for getting revenue. But so Leo was basically carrying me out of his pocket, which is I always respected him for that. But it also got to as he sort of put it in the final show that Twit produced for that, he said this was documenting, for 20 years. It really covered the beginning to the current state of open source as a forever archive of all of that stuff. And during my 13 years, I know that I interviewed huge people in the industry, the movers, the shakers, as I used to say every week, the movers, the shakers, the big projects, the little projects you may have never heard of but are using every day, projects you might want to play with right after the show. That was my usual opening dialogue for each of those. And I meant it, because that's what we brought on. That's the kind of people we had on that show. And there are projects that we put on the map because they appeared on our show. And within 6 months, they were having their own conferences and everything, like Salt. You might have heard of Salt. Salt was really like a tiny little thing. And they came on our show, and all of a sudden, boom, they're like one of the main configuration managers out there now. So that was a lot of fun. I wonder what Simon's doing now. I can riff for so long. Nobody's asking me any questions except Metaphysical Mind. See, we still have a dozen people out there listening and watching. So hopefully Simon will come back. I have to leave probably eventually. I am doing DJing in Second Life. DJing in Second Life for UTC -7 and UTC -8 midnight. So that's the time zone just to the east of me, plus the one I'm in now. That's Pacific, U.S. Pacific time. And I'm going to be playing songs, taking requests from the avatar characters that live in this particular section of Second Life that I've participated in for 5 or 6 years now. And so I've often done the DJing there. That's worked out pretty nice. From what era? What era of what? Era of the song?
Context, because we have a delay on the stream.
Yeah. I don't know. Yeah, I'm trying to figure out what I was saying right at the time you were typing. Doesn't matter. Yeah. What era of music? Oh, I do everything, but I typically, if nobody's requesting anything, I play 80s pop, Yeah, because it seems to come along pretty well with the kind of people that tend to show up at these things. In Second Life, I'd say the average person in real life is probably, in this group anyway, is probably 20 to 60. So the 80s music kind of fits pretty well for that crowd. But I get requests from all over, so I can try to manage as much as I can about what songs I can play. So I have access to a lot of songs in my playlists. So I try to get challenged sometimes. Go ahead, give me something I can't do. We'll see.
Right, should we crack on?
Go ahead. Yes, I think I've done enough.
Oh, that, yeah. Right.
Filled in.
Oh, baby.
I didn't answer this. The only question probably that was relevant that I didn't answer was what brought me to Flutter. I've told that story a dozen times before, though. So go listen to any place else I have been on stream somewhere. I'm sure I have given that story over and over again.
So,
in fact, go to It's All Widgets, which is a podcast as well as a website. If you go back in the podcast and go to the one where I was interviewed, I did describe how I got to Flutter in that episode in particular. There we go. Continue. Fireworks. Make fireworks.
Right. So we need a couple of things here, right? So we need a let's have a quick look. Where are we? Game. Okay. If we want to do collision detection, we have the level data here. So we need to understand level data itself is only a model right now. So we need to know a bit more about the game data and how we want to do that. We could do that. That was the it was fireworks, was it? Sorry. Yeah. Okay, so let's add. Just going to fill up about actor and the controller. Let's add something to our game and game screen. So if we tap someone on the screen, let's have it shoot a firework. Sounds like a good idea to me. Oh, I suppose we could do it on timer. We could add an. Oh, that's a good idea, Simon. Yeah, let's do that. Let's do that. All right, here we go. Let's do it. We're going to say add a new fireworks entity. Take advantage of our entity system. Fireworks. And then we could, like, when we use this later, when you end the level, we want to do the fireworks. We can do that. And then for the minute, we could do like an extension of this, which is like Happy New Year fireworks, right? So fireworks extends snow dash entity. It needs a update function and a render function. Oh, bosh. What I might do is have entity export. Yeah, let's have it export UI. This way, we don't need to import it because we're going to need it for canvas and size anyway. Yeah.
There's almost nobody that experienced the New Year's Eve 5 minutes ago. This is weird. Almost nobody. Huh. Just looking at the calendars here. Date and time.
Oh, I see what you mean. Yeah. Like because of the world time zones.
Not a lot of stuff that's out over on the west coast of Africa, for example. It's a little crazy for that. Let's see what I can find. World clock, extended world clock. There we go.
Okay. So fireworks. Gonna need. Why do I have the feeling of having this ID? Don't like it. why do we don't need ID as a parameter being passed in? As long as we have a way of getting the ID, that's what matters. That's better. Much nicer. You don't even need a constructor. Like
Oh, my apologies to anybody in the Azores, okay, out of Portugal, because there are probably 12 people that just experienced New Year's Eve. I don't think any of them are online right now.
For those that wanted, the whole ID thing is normally there so that you can go find an element, find an entity in the entity system by its ID.
Cool.
Because you might, let's say you have like 5 instances of fireworks, you'll find a specific one, then you could then label each one independently in some fashion, right? Okay.
Why would you make that a string instead of a type?
So this is what I was just thinking about earlier. So this is like why I was just thinking about this coming back from where I was earlier, thinking I got rid of type, but then like you one type. Let's say you have 5 enemies of the same enemy on the screen. They all have the same type, so you need to independently detect them different from each other, right? So
but they would have individual instances. That would be distinct.
Right, and that's where the ID is coming from, right? Like in terms of you may not have, you don't have it. If you had the object reference, you wouldn't need to go find the object.
Right.
Somebody's
got to hold the whole thing, though. Somebody's got to hold the whole registry,
which is the game, right? Which is the list of entities,
right.
And then that's why I'm saying you could. So what we normally have, well, let's do it here. Look, you would have like a, let's say, let's do iterable of entity. Now we can actually extend this a little bit better. We can say find entity or find entities. Find entity by, let's do it by ID. And that would have an extends entity string ID. And then we just say something like first where not iterable, this would just be E. Right. Right, and then if it's, we'll do a nice ending, we'll just say it's nullable, and we can have a first where or else null.
I'm going to step out for just a second. I'll be right back.
I know it's going to do that. That's a good point. That's a collection in. We'll just use that. We should actually add versions to these, shouldn't we? Let's get all them up. The guys on 210. We'll put in the latest, and then there'll be a conflict probably, and then we'll pull them back down. But let's have a pub get C. Oh no, we're good. All right, wonderful. The reason for doing that is there's an extension method which does this for me. What does it actually do? Just loop check does it. It works. we can get rid of all this. And we're doing the as E because we know that an entity is an E, but not particularly this one. So this might have a casting problem if the type that you're finding does not match the type you're trying to return. That's the nature of what we're trying to do. And then we'll have an iterable E find entities, and this can have a function test, and then this will just be a where so this particularly, that's a good point, match the type. Yeah, so we do where type E, then we can be guaranteed that we're going to return back an E here.
What'd I miss?
I was just adding in, so I added in collection, so we can do first where or null, make our lives easier. And I'm just adding in find entities here. Cool. And yeah, this is just matching the test condition then. There we go. So that's just a shortcut for where type where. It doesn't, it's not evaluating this at this point. That problem. Yeah, I think I'll change that just. That'll do. Right. So just some helper functions. Right. We'll come back to what we're doing. So we will probably be using those in a minute. Right. So get back to fireworks. Finally, come on.
Time is running out.
Time is always running out.
You got to come up with something before 6.5 hours from now, because my time is midnight.
Right, what do we want? How do we want? We could do snow as well. That might be a nice little addition. Snow and fireworks at the same time. Let's stress test the system. So I'm just going through some old stuff here. I guess we could say fireworks has a count. I guess. Come on, think. Fireworks can maintain a list of fire. Okay, now we get into this child relationship thing, right? Where we want, if we have fireworks as an entity as a whole, each firework should be an entity. Because they have properties, they accelerate into the air, and then when they explode, I guess we could treat each one of the particles that comes off of that as also the firework. This isn't really. It's like when do you. It's not really a particle system at this point. Okay, let's just give this a go.
Okay.
I'm thinking fireworks just maintains a set of particles, and when it renders those particles, and they're not actually objects. I think that works. Right, so let's do that. Update. Okay, we're going to keep it simple, right? We're going to keep it all in one file, keep it really simple. Happy New Year. Yeah, there's different ways of doing this. I think let's just keep it simple right now. So I want it so that when I tap on the screen or do something, it's going to initiate firework. So we're going to have a function here, add firework, right? So we want to be able to call this function in fireworks instance at the appropriate time. So we go back to our game screen. We're going to have it so that when we click on the screen, get back to where we actually started here. So wrap with gesture detector on tap. We're going to do something, and we need to somehow get reference to fireworks. So we have a reference to game. So game dot fireworks dot add firework, something like that. So now our instance of game needs to have a notion of fireworks. So if we do this, we can then say fireworks equals fireworks add entity fireworks. It's late. So for those that are kind of interested in this, this equals assignment can actually be done inside of an expression of a parameter. It does the same thing, so that achieves the same result. But it's sometimes confusing to people to read that you're assigning as well as returning that result, because the result of this assignment is the variable, the contents of the variable, which is then sent to add entity. You can do that if you want to. I'll leave it separate for simplicity. All right, so now we've got fireworks, and our game screen, if we scroll down, should now tap it and also add firework. That's our interaction with our front end. So now print add firework. Let's just see, and let's keep a count. And each time we add one, let's just, whoops. So there we go. I'm tapping and it's showing. So that's good.
Oh.
Okay. So what's next? So we're going to need a set of particles. So let's create a class particle. And our particles are all going to have very much like an entity. And this is why I was saying we could use entities, but we'll do it in here. Position, velocity, and what, acceleration. That is something else that we should probably want to export. Yeah, let's go with entity. Okay. Let's export vector math. So by doing these exports, we're saying anything includes snow-entity also gets all this stuff imported in for it. So it just saves us, we can just import that one import into all our entities and get the basics. Okay, so a particle has those things. I guess we can have a color attached to it as well. Since we're using, so then we'll, do we want to changing its color? I mean, why not? The reason why those above are final is because you edit the value. You don't actually reset it, whereas the color object itself is immutable. All right, so now we've got this private, this underscore makes it private. So we're going to get this little particle. Our fireworks are going to have a list of, let's call it particles. And it's the particle. And what we're going to see that's firework right now. We're going to pick a random position. That's interesting. So what we have, notice how big the screen is. It's not part of our system.
Hey, Simon, your audio is sounding garbled to me. Are you
Is
doing
it?
something differently?
It sounds fine here. I mean, nothing's
Sounds
different.
fine there. Sounds fine there.
Haven't changed anything.
Okay.
You need to leave and restart stream. Your stream.
I don't know. I don't
Does
think
anyone? Please tell us if anyone else hears it garbled. That's the main thing.
Yeah, maybe it's just me. It could just be me.
All right. Yeah, black. Yeah. Right. So 320 by 256 was what I made the play field. So let's make sure that's in game, just so that we can refer to that. Final size. Size, I guess. Okay. Again, it's. Oh, there was an issue apparently. Okay. Well, let us know if it happens again.
Yep.
I'll just show it all. Okay, so we'll get there eventually. Right, so we have a size on game. And this means down here we can now say X is, well, let's create a particle. Let's call it P equals particle P dot position dot X. There's a set, isn't there? Set values. There we go. So X is going to be game dot size dot. I guess we want a random. Quick run random instance.
Got to import math. Yep.
So we can say random next int next double times size width and we'll just say for height. All right, so this is going to choose a random position, and then we're going to add that to particles. Let's get rid of count. All right, so now during update,
That's weird that next double is always 0 to 1, but next int can give you whatever number you give it up to the upper bound.
Yeah, but so you got integer, you got discrete units of an integer, or next double doing this gives you a double out the end of it, right? Which means that you can get a fractional.
Yeah. I don't know. I just think it would be consistent, though, if next double took a double parameter and multiplied that for you, even all that's doing is multiplying.
It's all right.
Because that's kind of like what next int does. Sort of.
So I guess the velocity This is set. No, minus subtract. Okay, fine. That's just annoying. Okay, so we want to subtract acceleration from the velocity. Allow us to speed up or slow down. Then we want to update our X and Y. Yeah, we're going to update our that's a good point. I didn't think of that. Yes, add dot velocity. Right, I think I made a mistake earlier. Look, yeah, these should. I mean, we could update them. Yeah. Saves in a bit of so we're not churning the vector 2s all the time. Oh shit, chair. Right. So I'm going through some old code here. Can't share, I'm afraid. Just
why are you subtracting acceleration? Shouldn't it be adding? And with an acceleration that's negative?
Yeah.
Okay. Just curious. Maybe you were planning on making acceleration be deceleration all the time. I don't know.
That's what. Yeah, that's kind of whatever.
Okay. And technically, you should be integrating from the beginning and the ending of the delta time because you have two different values for velocity, but
yeah.
Whatever.
No, that's me. I wasn't. That's a good point. Actually, did I actually update that in entity as well? I did. Okay. All right. Render. Let's say render is canvas. Draw circle. Offset. I'm kind of fed up with this actually, so we're going to do an extension. Basically, we want to do vector 2 for the maths operations because offset doesn't support that, but we need offset for the rendering stuff. So there's always going to be a conversion back and forth at some point. So yeah. I'm just going to say extensions. I'm going to say extension offset vector 2, and we'll do a on offset, and we'll do the opposite way around. Extension vector 2 offset on vector 2. Was it? That's better. Right. It's input.ui and vector math. So we want to return a vector 2. In fact, we want to probably update a vector 2. So there's actually two things here. So let's say vector 2 to vector 2. I can just return a new vector 2 with dx dy. Simple enough. And then there's probably a set vector 2. And then we have vector 2 and offset, we can't offset the, so we'll just have a offset return
Oh, you're garbled again.
Am I?
Yeah, not now. It's I think it's when you get quieter. I think something's kicking in.
Well, I can try and move the mic. Hopefully that helps.
Okay. Well.
Right. All right. So 2 offset. That was it, and then we'll have offset. Right. So just some extension methods to make our lives easier. So we go back to here. This now becomes. We want to do this for each particle. So be p dot position dot to offset. Okay. And then radius we'll just do as 2 for now. Paint color equals p dot color. Okay, and that's can be nullable. So we'll just default it to colors.white, I guess. Or no, do you know what? We'll just say better that we later not treat null as a value, and when we create it, we'll set the color to equal primary, like a primary colors or something. Primaries, that's the one. So we should be able to do something like random next length kind of annoying. All right, well, anyway. Okay, so if I click on the screen, we should get a random dot appear somewhere on the screen. And since there's the all 0 velocity, 0 acceleration, they will have no movement to them. Sounds good. Let's see what happens.
Oh, sure.
I have a bug. Yes, because xy equals it's actually slightly better if we just do set values. Oops. Okay, back we go. Okay, we have black, so that means it worked. Okay, so, oh yeah, look, I tapped. I got a yellow dot. Let me make this bigger. Tap again. Yeah. Keep tapping. Keep tapping.
Oh, random dots all over the place.
Random dots appearing.
Well, that's one step.
That's our, but that's our initial like. So okay. Now what we have with that is we have a way of displaying particles.
Yep.
We have a way of. So now if we give particles a random amount of velocity at a random vector, then we'll have them moving around the screen. Then if we're during the update loop, we have bouncy balls at that point, but we could look at that and see if we're actually getting something working. I guess we could just start on the nature of what a firework is. So I guess
It's a shiny thing in the sky that decays and falls down based on acceleration pulling it towards Earth.
yeah, this was just hang on, just thinking. So we kind of want another model here, right? So some we need something to track the I guess each firework, right? So i.e. what state it's in and what particles belong to that firework. Because so the way I see this is we have one particle that proceeds, right? So that's like your thing you fire up into the air. Now we can actually start drawing that with like different sprites even, right? But different graphics, but it goes up into the air, and then when it reaches a certain when its acceleration decreases to 0 or a negative amount, we can then say, okay, time for you to explode, or we put like a timer on it or something, right? And then it's then going to turn to like 5, 10 other particles, right?
Right, and exploding in different directions, randomly spread out from it. Yeah.
I guess, do we want a trail as well, so that each thing kind of leaves a trail, because that's another additional piece, right?
Yeah. I think if you first just get the particles, then you can get the trail later, because you just have to maintain a historical position on them, I think.
All right, sorry. Say again. What were we just saying?
Oh boy, I have to recreate that. I think for now, just get the particles moving. You can worry about the trails.
All right. Well, I mean, like let's. So right now, if I add a particle, there's no reason why we can't say p dot velocity.
You should have a clone on your particle method, so you just say clone with, or that's a copy with. You get a copy with for.
Oh, I can just add. I can actually just set these values. In a constructor, right? It's not really a problem. I'm just
okay. I was trying to make it a little more realistic, that the copy with would mean that you could then say this particle is a fork of the other particle, but with this new acceleration.
That's not a bad shout. Yeah. Let's just see if this works. So if we want we could choose.
Actually, I bet it wouldn't change. Well, I'm trying to think. No, if it's a starburst, then each particle will have its own acceleration vector that'll be the normal to the original location. Well, the negative of that normal, away from the point of explosion.
Yeah.
What you got?
As they're going, I need to multiply these down by a very small fraction.
Oh,
there you go.
Oh yeah, you got bubbles. You're blowing bubbles. That's great. But they're not decaying from any kind of downward acceleration.
No. So we don't have gravity being applied, right?
Yeah.
So we need what is gravity in? I guess it depends on what. I mean, we're talking about pixels per second at the moment in our thing. We're not doing meters, or we're not doing any physical. So I guess we could do
except the bird has a logical size in our mind, so pixels must map to like 3 inches for the bird or something, right?
We could do it. We could do a physical mapping. I think we just apply a constant.
Yep.
It'd be what? Hang a minute.
Downward by meters per second
So
squared.
you want the velocity to
Well, no, yeah, you'll set the acceleration to the downward vector.
yeah, but so Hammy, let me just think. Gravity is going to slow it down.
Gravity is going to get added to the velocity as long as the acceleration for the gravity is downward. That's how that works.
Yeah. Hang on.
It's not sub, it's add once again, but okay.
Well, I'm going to do a negative number. Thank you very much. I have to do add. Fine. I really didn't care. Right. So if we were to
so the y downward, whatever that is, right? So it's -1 there or something. I don't know. That's going to be way too much, but.
oh yeah, it's like
just immediately falls. Well, it's fallen. It needs to be.
oh, that's cool.
Oh, I'm liking that, and it's still retaining a little bit of its horizontal velocity that it has.
Yeah, that's because I have no. It's because I have no acceleration on these right now, so they're not recouping anything on removing the velocity, right? So what we actually need to do is apply force, I guess.
Mm-hmm.
So when we create them, yeah, hang on. So let's say so if we when we create a particle, let's also create a constructor for this, because this is going to be not a bit sort of crazy.
If only Flutter had some sort of physics built in. That was sort of a nudge, but maybe you didn't.
For what?
The hook. If only Flutter had some sort of physics library built in.
Does it?
Doesn't it? Sure it does. Yeah.
Not for me. Vector Math doesn't have that. That would be the only thing I can think of that would actually do physics. Oh, you mean like the physics for like animations and stuff? No.
Yeah, exactly.
No, they're not. They don't work in that way.
Gravity simulation, a simulation that applies a constant accelerating force.
It's not the same thing.
You don't think so?
Nope. Like going to and from those data types is just not worth it.
Yeah, okay.
In the end of the day, it's no dissimilar from what we're doing. I'm just going to see if there's actually any nice things in here. But yeah, come back to that another time, right? Right. Yeah, we can't do that, can we? I guess you know what we could do at a pinch is still treat this as final, but they're late final. And then this becomes Well, there might be a better way, but I can't bother with it right now. Okay, and then we'll have just a color. Okay, I guess we'll do something. Why not? And you were saying like maybe a clone function. Yeah, I can see that. So we can add something like particle. Clone with acceleration.
Right.
Clone with force.
Generic copy with, and just give it an acceleration parameter.
We just have a clone, and then you know, I think we'll just do a clone, and then the rest can come independent.
Yeah.
Did I just implement that for me? I know what option I chose, but apparently it did it. Right.
Okay.
Okay, so now, yeah, why? Well, oh my god, what have I gone? Anyway, why am I getting an error? I shouldn't be getting an error because all of these are optional. Oh no, because I put required. That is because of me. There we go. Okay, so now position. Oops. Can be a vector 2 with our initial position on it. Much nicer. I mean, we're not going to have random dots like this, so this is a bit what's the word? Contrived. We'll start. I think we'll have to start wrapping up in a minute. We're going for some time. Let's see if we can get a bit more of this done. Right, and then colors.
Yeah, my giant T thing is already empty of T now. Coming up on 3 hours.
Okay. I completely forgot what I was even doing. Oh yeah, that was it. So we add force. I added, right? Yeah. So I guess we want a force of an upwards vector, and then gravity is going to be bring it back down.
Yeah, velocity is going to have to be initially up, and then acceleration gravity will be pointing straight down.
Yeah, so we can do like a. Oh wow, negative is down, so positive is going up.
For y positive's down, isn't it?
It's however we do it in our system, right?
You have lower left be 0, 0, right? It's not the way.
Lating. Okay. What did I do? Acceleration.
We have more people watching now than we did an hour ago.
Does that mean we want to continue a bit more? What is going wrong here? It's literally just told me it's not initialized program. I think it's this. Yeah. Dope. Right. It blew up. Something blew up.
Oh gosh.
The color has not been initialized. Oh, same thing like this. Color. Try again. Restart.
Blew up a different way.
And now I think it's still going from before. Just need to.
Well,
Maybe I'll kill it. Get rid of the backlog. Because I didn't got again. Okay, wait. I don't see anything. So let's maybe that I wait. Drop it right down.
Your voice is burbly again to me.
Yeah. Okay.
Now it's fine again. Why is it doing that? Is it something in the anti-echo?
No, hang on. Well, oh, my audio.
Your audio went blurby again.
I don't know what's going on there. Couldn't tell you.
I don't know. Somebody's messing with something.
It's the internet. The tubes are too small.
The tubes are on vacation because it's New Year's Eve.
That's the problem.
Okay.
It's interesting. So I'm just trying to understand, like, add force, adds it to acceleration. Acceleration. Okay. Sorry, I think I see what's going wrong here. My acceleration is in opposing axis right now. Because one of these is a sub when it should be an add. That's why I fucking just yeah. Right, hang on. Right.
Always keep your pluses and minuses in the same direction. And then it's add.
Yeah, but the thing is, if I want my Y to go up, right? Hang on.
That should be add.
It's my velocity. Here it is here. So if my velocity going up is 3 times greater than gravity coming down, what is going on? Okay, apparently you don't want a hot sink. So basically, our initial force going upwards is going to be 3 times gravity. And then we'll probably have
Your
to go.
acceleration should not change in update. Acceleration is going to be constant.
No, because gravity is affecting accelerate. Hang on.
No, gravity is the acceleration.
Right, but acceleration is not no. The point here is I need it to slow down, but we don't adjust the acceleration. Right? Hang on. Oh,
I'm pretty sure acceleration is a constant. In the absence of it having little thruster motors or something. If I drop a ball, it's going to fall at 9.8 meters per second. That's constant. So acceleration is not changing.
Right, but then what I'm trying to say is here is are we then saying
acceleration gets integrated into velocity, velocity gets integrated into position?
Yes. How do we want it to apply gravity?
An acceleration of down by 9.8 meters per second squared.
Right. So that's what I'm trying to say. Like we don't need to integrate that on every
Yes, that's what I've said. I'm trying to figure out why you're adding acceleration is one of the things you're changing. Don't change acceleration. Acceleration is constant. It's always
Yeah,
going to be constant.
my initial velocity. Yeah.
Yeah. We're doing basic physics here now. This is great. It's stuff I remember from junior high. Barely.
So if I put this at 0, 0, and then we just tap, we're going to go at constant velocity in whatever direction we're saying. So
Does the particle have an acceleration value, or is the acceleration global?
no, that's what I'm trying to say. Like that's what I'm trying to say. If we're doing it in the update method, then it would be global. Yeah, let me just get to what I was trying to get to here.
Why are we using force? Because it's not working otherwise.
No, that's what I was looking for. Hang on. That's it. That's what I want. Right. So now the problem here is the y needs to be so we go up and then back down it comes.
Yeah, there we go. It bounces up for a little while, then it starts accelerating downward. I like it. Ship it. Ship it.
Get some more force.
Nice. We're flinging balls. Q how Tio? What is that?
Well, there's a bit more to this, but I think that's kind of a nice. I think. I mean, at the moment we don't even destroy it. They're still calculating, but even when they got off the screen, they're still calculating right now.
Yep.
We don't destroy it. We just keep adding more.
Yep.
So yeah, this does actually need a bit more in terms of. Well, we could actually say this like if p dot position.
Oh, Pradeep, we're not answering general Flutter questions right now. We're just trying to focus on the game. So if you had game questions, feel free to ask, but otherwise save that for Wednesday.
There's an AABB, isn't there? There's an AABB. AABB 2. Does it have like a contains? Rotate, transform, transformed. Contains another contains vector 2. Sweet. So we could actually have.
You want to have something when it goes off the edge of the play field?
Yeah, we'll just do a quick playfield. It's AABB2 dot. Is it min max? I can't remember. Literally just looking at it.
Do the particles have mass? I guess they have to, or they're not affected by gravity.
Yeah. We should probably do the proper.
The force for gravity is not dependent on the mass. Well, I guess it does, because the thing is the Earth just dwarfs the size of the or the mass of the small object, so it doesn't really matter for the Earth. That's an interesting question. Does the gravitational constant change based on the mass of the object?
I mean, we don't need to be physically accurate.
I'm asking Bard though. I want to see, does the gravitational constant depend on the mass of the object and or the distance from the Earth? G doesn't depend on the mass of any object or its distance from Earth. It's a fundamental constant of the universe? What? No, this can't be right.
Well, gravity, yeah.
The force of gravity does depend. Oh, you have to work in m1 times m2 divided by r squared times g yields the accelerators that we're going to use. Yeah. So there's some math in there. So it's not 9.8 blah blah.
There we go. So
right.
let's see if this works. And make a bunch of them. If they disappear, they should disappear just before the edge of the screen. Yeah.
Oh, look at that. Poof, poof, poof. They should explode then too. That's next. That's kind of cool though. That's kind of fun.
So we can now, I'll put that in the proper limits here.
Pradeep, I answered that by saying we're not going to answer that tonight. So today, tomorrow, tonight, whatever Wednesday, it is for you.
That's a Wednesday problem. So, yeah,
Come back on Wednesday. Come back on Wednesday and ask that question. That's a good question.
If the gameplay field does not contain the position anymore, then remove it. Right?
Yep.
I mean, yeah, let's. Bigger dots than our balloons.
Ooh, yeah. And they should wear down from friction. Friction should make them smaller. So let's compute friction based on the speed times the size of the ball.
Oh, God. Right. But anyway, it's a good starting point.
It is. It's pretty. I like it.
I think we'll do some more over the next period. I don't know. We'll see. Do people enjoy this? Do they want to see more? We can carry this on as an independent to Wednesday's normal show.
We didn't see many. We didn't lose too many people. We did have some interaction. I think if we announced it further in advance, so if we announced it on Wednesday for next weekend, I think that might actually be good.
Good.
Tell everybody to watch the skies. Look for signs that there might be a stream coming soon.
Well, I mean, we can. Yeah, we'll decide. I'll tell you what we'll do. We'll post up. I'll post up on Twitter on my follow me at Dev Angels London, and I'll announce there when the following schedule is. Me and Randall will have a chat about that, and then I'll block it out.
Yeah, like I'm open all weekend next weekend too. So if you want to do anything anytime there, it's fine. I've got nowhere else to go.
Cool. And I'm sure we'll speak soon.
Alrighty. Happy New Year, guys. Happy New Year's.
Happy New Year. We didn't get to fireworks totally, but next time. That's the way
we got some fireworks.
Indeed.
We got some fireworks.
All right. Thanks very much. And we'll see you guys soon. Bye.